Right. So what we're doing, right? Okay. So what we're going to do here is they've just okay. So what we're going to do here, they've just released the new version of Isaac Sim. It's not officially out, so I'm just going to bring up Omniverse just now. Launch the launcher. So we're going to go into the exchange, and if you type here, let's go look at Isaac Sim, and then here we go. Compatibility check. I don't know. What's this extra one? There's an extra one here. Don't know what that is. So you can go here, and then if you go to all release builds, and then you can see here we've got Isaac Sim 4.0.0. So cool. Right, so I've already installed this. So I'll just bring this up, and then we can see here I've got my selection. Why is that not doing? Oh, right, it's because that's why it is. So this is the one we're launching 4.0.0. Right, so let's go for it. Let's launch this, and I'm going to show you something very cool in a minute. Very, very cool. So while this is launching, we don't want to touch it because it'll just break it as usual. You can't touch anything when you launch. What's it doing? What is it doing? Here we go. Right, okay, we're getting someone out. Let's try this. Boom. So I'm just waiting just now, see if it's going to play ball. Nothing. This is like Isaac Sim. This is my life. Oh, here we go. Right, it's on the move. But one thing I will say, I'm streaming to Sim. Sorry, I'm streaming to OBS and I'm streaming to the Discord, so that might affect my performance a little bit. So take that into account, right? So while that's doing its thing, there's one thing, there's one error in here. I think it's the old lidar. I had a look at that earlier. Just booted up for a minute, but check this out. Now, this is VS Code we're in now, and you can see here there's an extension now for Isaac Sim. And then if you look at the release date, the published release was only like literally 12 days ago. So that's pretty cool. Um, right, so this here we are, right? So we've basically got this released 12 days ago, and this is a game changer. This is absolutely brilliant. So Isaac Sim VS Code Edition, right? And key features, let's just go straight into it. Execute Python code, blah 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 as usual. Um, in the Python environment of an Omniverse application locally or remotely, yada 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 yada. Right. So basically, what you can do is you can run your VS Code as you would run in script editor. You can run that in VS Code, and I just think, well done, guys. Well done, boys and girls. Fantastic work. This is really really good. This is brilliant. This is what we're talking about here, and because it really comes down to the integration. It really comes down to the integration between Isaac Sim and VS Code. So you've got that interplay between the code and the sim, right? Brilliant. Well done. Really, really happy with this. Really happy with this. I'm going to install this later. I'm not going to do it just now because there's obviously, a bit of playing about with this. This is brilliant as well. The snippets, amazing. Absolutely amazing. This is like, I can't, like, this is, yeah, maybe this should have been here at the start, but look, I'm not getting on it. This is brilliant. I'm really, really happy. Um, you can do things remotely or whatever. There's some thoughts I've got about that, but it doesn't matter. What else here? So I really like this. The snippets. This is brilliant. And then you've got different ways you can run it. That's brilliant as well. Templates, brilliant. Docs, didn't see that. Brilliant. Well done. Really, really good. Really pleased with that. Okay, let's go on. So I'll install this just now, right? Just see if it actually works. And it does. Look at that. Now, when you look into this a little bit more, let's get, you come down here and you can see the settings here. I'm going to do this later. I'm going to get this working later. I'm not going to do it when I'm streaming because I want to sort of just look at 4.0. So let's see if it's, and we're running, right? So as I said before, that I'm running OBS and uh, and I'm streaming to the Discord. Now that frame rate is absolutely mental. That is a lot better than it was before. I've got no scene loaded, and I've got a frame rate of 470 frames a second. Uh, I'm pretty sure that's a lot better than it was before. So I'm just going to have a little look about and see, see some changes. So I think what we'll do first is we'll go back to the launcher and let's just have a look at the little blurb here. So let's look at the features, Right, we all know if you use Isaac Sim, you know what it is. It's robotics, synthetic data generation, yada yada yada, like, Omniverse, bit with Omniverse, GPU, physics 5, photorealistic ray tracing, all that good stuff, right? Um Isaac Sim is a physically accurate virtual environment to develop, test, and manage AI-based robots and provide essential features for building robotics experiments. Brilliant. All happy days, So this is what Isaac Sim is for those that don't know. Right, let's go into the features, right? Um, you can basically import a bunch of stuff and simulate sensors. And this is the big thing for the robotics, right? So you can do sensors such as RGBD. So you've got your RGB channels for your color cameras, your normal cameras, and depth. So obviously you've got that range. The physics, LiDAR, I don't use that. RTX LiDAR, fantastic, brilliant. And I'll go into more detail on that another time. Radar, amazing. Contact sensors and IMU. Um, Supports various robot applications, including navigation, manipulation. And I did have a look through some of this stuff earlier, and you've got some really cool stuff in this that I noticed, and I'll come back to that. For AI applications, blah 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 blah. Replicator, synthetic data. So that's just like randomizing domains. So you can create um, synthetic data to generate to train AI models. Then you would create create a model of that, and then you would run inference on that model, which would then be like a sort of action or prediction or whatever it is that you want it to do. So basically for reinforcement learning, brilliant. Yeah, Isaac Gym. Did it not change that? I think that's wrong. I think that should be Isaac Lab. I think there's actually an error there. Anyway, doesn't matter. Ah, for development tools, Isaac Sim includes Isaac Sim Core API, Isaac Sim Orbit and Cortex. Isaac Sim API is a robotics abstraction layer which hides USD complexity. Isaac Orbit provides a ready development environment, and Cortex for high level decision programming. I thought this was all in lab. I don't know. Like the documentation, has it been released for this or has it? Let's click in the documentation, see if it does anything. Ah, and here's the docs. I didn't think the docs had been released yet, but here we go. I like this. This is cool. This is like fun. I like this. I like the little the first screen because it kind of shows you what it's capable of, and there's a lot going on, and that's brilliant. I like that. I'm not going to read all this because I'm not the best orator. So let's just have a look. Yeah, so it's good that it seems to be coming together about what what tools other people are using, and that's one thing that I think the Isaac Sim team have been getting better at. They have been getting better at that. They've been sort of looking at what people are using, and whether that's like what tools designers are using to create things, or um, for example, like the work that they're doing with Siemens. Like I'm a big fan of that. I think that's a brilliant, like two two titans of industry coming together and working together, and particularly with where this is all going to go in the future with robotics training. The brilliant, just can't go over how brilliant the team is. Um, so you've got all this different formats. You've got on shape, USD. Brilliant. That USD, I'm trying to encourage a lot. I work with a lot of robotics companies, and I'm trying to encourage them to go USD because I mean everybody's doing it. So yeah, can't be happier. Just gonna have a little drink of my coffee. So it's got all this stuff. Um, tune and train. Yeah, blah 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 blah. Different sensors. Blah blah blah. Omnigraph, absolutely brilliant. Omnigraph is fantastic. Physics simulation, brilliant. Ah, right. With Isaac Lab. Now, I don't understand why when you go here, it's sort of talking about orbit and I orbit and what was the other one? Yeah, Cortex and things like that. Yeah, I thought that they'd kind of get rid of this, and it was just because GTC they were talking about the Isaac Lab, and now when you read down in this documentation, it says here Isaac Lab. Let's have a look at that later. Um, Now the API thing about deploying, I like this, right? I like that the fact is that they're maybe putting a more importance on deploying the models. It's not just about generating the data and stuff like that. That's that's like a really good sign that it's sort of the different stages that's involved in creating these models are becoming more integrated and aligned technically along the way. This is cool. I like the way this is going. So they're going straight into the Isaac Sim API, USD API, GUI API. I'll maybe look at that later. Um, Omniverse Kit programming. Kit, I really like the idea of Kit. That's brilliant. I think there's a lot. I don't think that the adoption for that's been as good as it should have been. I think that there's, and it's maybe just the bar at entry for developers, but I've got other thoughts on that. Um, let's have a look. Right, getting started. So we're not going to go through all this. I need to start looking into the container installation. I had a little play with that today. Didn't really get all the way through it. The container, I like the idea of a container that you can basically get all this stuff used so that you can just basically deploy entire systems, whether you've built something on Kit or you've created a model or whatever, and it's all just integrated in a container, and I can just go and take that container and then deploy it as per I need it in whatever device, whether it's an edge device or I don't know, something local that I'm building or whatever. That's something. Introduction, forget that. GUI, forget that. Development tools, forget that just now. Core API, scene setup, motion generation, ROS 2. I need to look into ROS 2. I've been kind of told to do that. Right, here's a good one. Mapping. Occupancy map generation. Brilliant. Brilliant. Love this, right? Because I've seen a lot of stuff. I think it's SPDF or something like that, and it's basically it's a voxelized system to create occupancy grids so that not only does the robot sort of know where it is, but it's using its depth cameras and sensors to see what's around it and then generate a map of the world using that. Similar to Slam. If you're familiar with Slam, it's sort of like that. Isaac Lab tutorials, brilliant, well done. Brilliant, fantastic. Replicator tutorials, brilliant. Isaac Cortez, brilliant. Oh my god, this is really good. This is really good. Well done. I like that you've done because they have listened because they were looking for a lot of feedback and this stuff is great, because they've actually took the time here. They've took the time to do the tutorials. We might do the tutorials one day. Right. System architecture. Let's have a look at this. I like when they can do this stuff. Yep. Yep. So you've got all your file formats that you might use. Here's sort of the set. This is sort of like I guess that would more be Um, what this is sort of more in the program itself that you're sort of building. This is more what you're building, um, inside actual Isaac Sim. And then this is great, you've got your Isaac Lab, RL, and Replicator. This is really well done. I really like the way they've done this design. This sort of like makes it really visual, really easy to understand. Brilliant work again. And then your deployment, obviously, your ROS, your database, cloud, or local app, whatever you're going to do. Um, we'll just kind of run through this. Don't want to buy a house right now. Uh, yeah, this is kind of easy, like nice to read and stuff. Yeah, I think this is something that it's good that they're doing a lot of stuff we see. Um, obviously for the speed, for using CUDA and whatnot. Um, but Python, let's be honest here, it's like Python is like you know, even for people that's not from a computer science background like myself, this is really great. Deployment workflows. Um, yeah, it's Jupyter Labs, but I'm more a VS Code kind of guy. You've got your Python overarching, and then you've got your Jupyter notebooks, and then I don't really know what that is actually. I don't know what that is. I don't know if that's a logo or it's supposed to be something else. Anyway, USD, just going on more about USD. If you don't know what USD is, look it up. Um, OpenUSD that is. So go down there. Right. Okay, release notes. Right. This is great. Brilliant landing page. Brilliant. Release notes. Let's have a look. Based on so the new version of Kit's out says 106 compatibility, VS Code integration again, brilliant. Jupyter notebooks, that's brilliant as well. That's really good, and I think that will help a lot of people, that maybe aren't like programmers. I prefer to have my code sort of like running, sort of like kind of live. Right. What else we got? This is sort of clever. I don't really Isaac's because I think this is they're basically saying here Isaac. It's all Isaac's. I'm using Python package manager such as pip, right? So you can do pip installs in Python, which is great. Now this is obviously more to do with the API side. Okay, cool. I like that. That's good. Right. Yeah, this is good. Improved cache and shader experience. So I did notice that it crashed a couple of times when I was trying to load up the first time because it basically the first time it ran the cache first before it ran, and then that sort of just closed itself and went away. Then it opened it up, it crashed because what it normally does is it loads up and it's doing the shaders, caching, and that normally takes a while. So sometimes when you're booting up Isaac Sim for the first time in a new install, it takes a long time. But this is really cool. This is great. So I'm glad they've kind of improved that. Eco mode when not simulating. I don't know what. I mean, maybe that's a good thing. There's probably been some thought put into that. Use eco mode to reduce GPU consumption when not simulating. I don't know. I don't know. I mean, it's just obviously that's something they've looked into. Performance improvements, yeah. There's a lot of clever people there, so they'll be working hard to do this stuff. Right, big one: documentation and workflows tutorials. Brilliant, because they done what they done a while ago was they done a lot of work looking at what were they looking at? They were looking at basically how people are using it and the questions people have got because that's quite a complex problem because you've got people coming in from all different industries. So that's quite a it's a big ask, because this software, Omniverse in general, can be used for anything. I mean, that's the Omni and Omniverse. Um, so that is yeah, that is something that is a tough gig to get this right. Right, so here we go. Yep, and then I was right enough. Orbit is they're kicking Orbit out, and it is going to be Isaac Lab, which is a very very good idea because like that was one of the things. Like, why is everything all in different places? Can we not just have one thing that's cohesive? And they've done that. Brilliant work again. Um, I would need to look into that. I'm not really sure what that is. So basically, the Isaac Lab and migration. That's good. They've done that, so people's previous work can be then carried over. Brilliant. Um, Cloud based, everything in Isaac Lab. So if you don't really know what Isaac Lab is, it's basically where you would once you've built your simulation and built your randomization domains, you can then run that in the lab and then basically use reinforcement learning to improve it. So that is I want to live inside Isaac Lab once because I've got more projects coming up, really really interesting stuff. Um, assets and ports, I yeah, simulation fundamental. That's a good one. Simulation fundamentals. Yeah, the merge meshing tool. I don't really know why you need that. Um, articulation loop. Don't know. Got a rumbling belly. I need to go and get some food soon. Assets and import OmniGraph menu shortcuts. I'll need to kind of check that out. This is good that they put in the motion blur because I know that was one thing that I'd seen in the forums before, and what they were talking about is when the camera is taking its frames in the SDG, it's basically not um it wasn't including like a motion blur. So obviously that would then throw out your the way a normal camera would work with shutter speed and stuff. So that's good. Custom FPS. So what? Sorry, we're chatting about synthetic data generation. So that's like generating data inside Isaac Lab that's then used to be processed later to train these AI models, right? So that's what we're talking about here. Um, Standalone randomizer, physics-based volume filling. Oh, volume filling. That's good. That's good. I like that. Omnigraph based randomizer. Ah, right. So here's another good one. Custom replicator omnigraph based randomization nodes. That's good. That's good because I like to do a lot of stuff in Omnigraph, and the reason I like to do it is because you can sort of you don't need to be looking at everything just in a code space. You can sort of look at things as concepts, like the way you would do a whiteboard. So and then you can sort of dig into that, and you can sort of set your whiteboard out with your conceptual ideas and sort of fill in the blanks with the code along the way and how the numbers will flow and how the data will flow. Um, oh, that was that Synthetica tutorial. Don't know what Synthetica is, but it sounds kind of sexy. I like the sound of that. Right, Rose one, Rose two, Rose Bridge. Yep, bunch of raw stuff. I need to get into that. Right. Okay, Isaac Lab. Here we go. Unified RL platform. Brilliant. Open source with BSD free license. Don't know what that is. Uh, don't know what a lot of this stuff is. Perf improvements. Don't know. Multi GPU training based on PyTorch. Great. Aye. Yeah, because that's one thing that basically, if you're going to be doing sort of cloud based stuff, or you've got your own local, maybe you've got a lot of GPUs and you want to do that. Really, really cool. So you can basically do multiple instances of uh, training runs, well, multiple instances of your randomized scene to then create more data. Recording capabilities, animation, video, great. Tiled RGB in depth, rendering with an I don't really know what that is. Physics, more joint work. They had to do. I'm not going to go into all this stuff, but they did have more work to do on the physics side because they had a lot of uh, jankiness, shall we say. And it's not that these people are wrong. It's that the fact is when you're trying to transfer real world physics into a computer, there is obviously going to be stuff that's sort of lost in translation because there's so many factors in reality, and then trying to compute that, it's a tough gig, right? So we're not going to go over this. It's just a bit. I'm sure there's a lot of really great stuff, to go into there. Assets, imports, let's have a swatch. Um, that's good. Good wizard guide. Da-da-da-da-da. Yeah, new assets. So they've got the sick safety lidars. Great, they're a great company. Oyster, I don't know, Oyster, OS2, and they've added meshes for the other ones. Meshes for the Velodyne, meshes for sensing cameras module. Okay, so they've got some new um environments. I don't know what I don't know what this Rivermark Plaza is. I did see that. Right, okay, new robots. So you've got a bunch of robots. We're not going to go into all that. Legged robots, Unitree. I actually seen one of them at GTC. Um, oh, they've got Spot. You put Spot in it. What? Magic, magic. Right, humanoids. They've got a bunch of humanoid stuff. That's cool because it's sort of, you can see how um we can use um Isaac Lab and Cortex to basically create brains, but we can also use, because I know that, again, going back to GTC, there's a big focus on NIMS. I'm not going to try and go into this because I'll mess it up if I go into NIMS. But basically, it's this idea of like also like foundational models and stuff like that. So basically, we don't need to retrain all this data, right? We don't need to like run the same. Like, what's the point of me running a crap or a very poor model to try and run a humanoid robot when there's plenty of companies that have got the resources and the money, such as Nvidia or other robotics companies that have basically got the resources to run these huge models to get really good models, instead of me trying to do it on a 390 Ti or a 390. It's just no point. There's no point me trying to do it when, you could be having it running on like some monstrosity of like these supercomputers that they've got now. I'm forgetting which one we're on just now. I mean, I seen it and it was the NV Link and all the rest of it. So I forget what it's called now. Anyway, it doesn't matter. Right, brilliant. Nova Carter Rose forklift. Ah, that's cool. Forklift B crown. I don't know what that is. Let's Google that actually. What's this thing? So they're actually putting a real forklift in, right? With raw support with cameras and lidars. That's cool. What does this thing look like? All right, right. So this is what we're looking at here. Right. So basically, it's this guy here. So it's basically a fully automated, uh, like a fully automated, what do you call that? Forklift. Right. Great. Brilliant. SDG custom writer for pose estimation. Right. Okay. I can see I can see a lot of good coming out of that because the pose estimation, obviously you'll try to see what's the shape of a figure and a scene that could be coming for a camera, that could be coming for lidar. I don't know about how good you can. I mean, I suppose Kinect's been doing it with depth cameras for a while, so yeah, I take that back. Yeah, it is useful. Coco writer, great. Yeah, that's really good. I've seen a few people looking into that. I've no idea what enable RTX non-visual materials. I would need to look into what that actually means. I can kind of imagine what it means, but I'm not. I don't think. Radar support, yeah, I've got some other ideas there, but we'll go into that another time. Performance improvements to Omnigraphs based on sensor pipelines, yes, please. I know that the guys that have been working on this have put a lot of effort into this, like a lot of effort, like, and it's not easy. It's absolutely not easy. So hats off to you boys. It's great to see that there has been improvements there. Um, I am use sensor backend changed to Tensor API. Yeah, so I think what they're saying there is basically it's more in a format to for this tensor API, which is like not something I use yet, but very, very good. Ross, I'm no the big Ross guy, but let's have a wee chat about this anyway. Let's just go through it, and I'll skip the bits I don't know. Performance improved for image-based publishers. Yeah. I did libraries. Don't know what that is. Static publisher. Option for TensorFlow publishing. Ah, right, that's quite cool. Omnigraph node to expose articulation states, joint position, velocity, and effort. Okay, very, very good. Um, Now, this is cool. This is the kind of thing that there should be more of this. Not more of this, but like just this, but done well. Generic ROS 2 publisher and subscriber for any available message type. Brilliant. Right, this is cool because what the way that Omnigraph works, um, I like that. I like the idea of having message buses and like basically be able to send any information because you might have custom attributes in your USD that are dynamic, and maybe that then needs to be sent to something to run inference on it, right? So, or you know what I mean. Um, Server and client messages, yeah, I don't do any online stuff. Right, there you go. So that's cool as well. Roster service on the graph node to list prims and their attributes as well as read and write specific. Yeah, very, very good. Um, transport tree. I need to have a look at that. I don't know what that is. Yeah, yeah. URDF, obviously that's like a robotic sort of CAD file. Um, yep. Preset. I don't know. I need to look into that. That sounds kind of cool. Don't know what that's in there. Manipulation. Right. Some other stuff I don't know. Yeah, it's good that they're putting in stuff about tuning. You know, basically sort of like a PID sort of thing. Um, I don't know what this is. This global. I think this is more to do with um inverse kinematics and spatial awareness of your arms. Very good. Metro Sim. Right. This is more like spatial, sort of like city stuff. I don't know what that is. I've seen some cool people in the animation, the people animation is very good. I don't know what the rest of this is. Don't know what that is. Um, I'm not going to go through this because it's obviously going to be a lot here. If I see anything, shout it out. Right, there's going to be a lot here, isn't there? Do you know what I mean? I'm not going through all this. No, that's an absolute buzzkill. Um, right. Let's see where are we? Installation. We don't need any of that. Conventions. We don't need that. The forums. Glad to put that right at the top because the forums aren't used as much as should be. I think you've got a bit of a split between the Discord people and the forum people. I used to be in the forums and I kind of went that way. But if you want the devs' attention, go to the forums because you can't be messaging devs try to get them to fix your problem, right? It's your Isaac Sim project is your problem. It's not the dev's problem. So I'm just being pretty straight with that because it's. I think when I started, I was just sort of like messaging them all the time, and you've got to realize like these people have got a day job, and that's to make Isaac Sim better. It's not to help you finish your problem. But the forums are a great place when these people kind of sort of can jump on and help you out. But forums great. Right, let's have a look. Tips, fundamental physics. I'm not going to go through any of that stuff. Um, Not going to go through that. No, this is all good stuff. Build your first virtual environment development tools. Core API. Definitely, that's something that I'm going to be looking into more. Scene setup, ROS 2, Isaac Lab. Let's have a look at Isaac Lab. Right. Okay. This is great. Examples for reinforcement learning. Thank you. Brilliant. Brilliant. Imitation learning. Brilliant. And more. Brilliant. Fantastic. Cannot thank, you know, the team enough for what they've done. Right? They have done a great job here. This is really good. Because this is what's that people don't get. Like if you're not a dev, but you've got an idea, and even people that are devs, because like nobody knows this stuff. It's really, really early days. I mean, how long has how long has Isaac Sim even been out? I mean, how long's when did they start reinforcement learning? It wasn't even that long ago. Like, let's think. Rocket League. Don't want to know about Rocket League. Right, okay, right, I'm not gonna bother with that. Support for different reinforcement learning intimidation lab. That's good. Yeah. Optimize for performance like that. Yeah, that's cool as well. Like gamepads, keyboards. Right, here we go. Right, this is clever. Right, this is clever. So we need more of this. This is the kind of thing that basically because this sim to real transfer, right? This is where it all is. You can simulate all the stuff you want, but see until you deploy, it's just playing video games. That's it. And until you actually deploy it and make it work, you're just playing video games. So yeah, I really like this. That with these custom actuator models for simple rule transfer, brilliant. Right, so this is sort of I was saying at the beginning when I booted this up. Basically, they've deprecated all this stuff. Right, brilliant. Because this again cohesive, brilliant, really really good. Um, right, that'll do for that. Get started. Right, so we'll need to go and do some more stuff with that. Overview, frameworks, additional tutorials, replicator. Let's just pardon me. Yeah, load of synthetic data stuff. I like this. Let's just have a look through and just see how easy it is, how readable it is. Yeah, nice and easy. Have they fixed this yet? Let's see if they fixed this. Distance to play damage. No, they've not. See, I don't understand. Why did they not put? I don't know. I thought that they would have put in RTX slider in here, and they've not. I don't know if that's just maybe I'm just not like got a good idea about this. But that stuff is really really cool. This is where the money's at, is this stuff, and it's like the stuff that they've made is brilliant. The stuff that they've made is really 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 good. So you can see a warehouse being simulated, and then they're just bringing up all the different types of synthetic data, that you can then capture then to train your model. So this is all good stuff. Um, right, this looks the same as it was before. They haven't really changed anything here. Um, right, I'll need to go into this and sort of dig deep on this stuff. Um, SDG tutorials. Right, let's see. Pose estimates the randomization and simulation. Yeah, bunch of other stuff. Online generation. Let's have a look at this. Yeah, right. This. This is where we're talking. This is where it's at. Right. I like this. I like this. The online generation, because then you don't need huge data sets. Like you don't need. I don't need to go and buy, you know, 80 terabytes of SSD storage because you can run online, and it just runs and runs and runs and runs and runs, and it's just feeding the data directly into the DNN. Obviously, it's different because it's not like you're storing, because you're running your training and you're running your model at the same time. Whereas if you are just running your model and then you created the data, then you've got the data set, and then you can take the data set and then put that back into you can put that data then back into the model, and then you're just running. So you're running compute twice, but when you're running it online, you're running twice as much. Well, twice as much compute. You're running both compute costs at the same time because you're running your model and you're running the thing. But I like the idea of this because I think as well, if you're doing PyTorch as well, and then so if you're training these DNNs, um, basically this is very very good, very very good. I like to put this in. Um, Aye, there we go. So you can sort of see that by your training data and whatnot. I like that it's happening. There's a lot here. Um, this looks like they've done a really good job of the. They've done a really good job here. Um, how they're doing this. This is cool. And they've actually, do you know what as well? They've actually put a lot of work into making it clear. Good, good estimation, right? Aye, so they've got these data sets now. I know. Um, blah 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 blah, different data sets and whatnot. Um, yeah, so basically pose estimations about kind oh, this is quite deep. This is going deep. But that's good because it's going to give you, and it looks really clear the way they've written this. Like output writing, right? There you go. Rep, create camera, blah blah blah. Right. This is great. This is really, really good. They've made they've made it really clear. Like, even though I'll probably need to read over this and I'll get confused, they've done a really good job here. This is great. Um, Summary. Let's have a look at the summary. How do we get the summary? Next steps. Oh, we'll do that. Go. All right. All right. I'm clicking the same link. MR navigation. I don't know. I've kind of lost here. Right. Like this. This is very cool. Yeah, so it's sort of pick and place, and then you're using different semantic segmentation to basically instant segmentation basically to see the different items in the scene. Very very cool. Very very good work. Oh, look at that. Look at that. I love that. Full code. Love that as well. This is great. Very very cool. And obviously there's a lot in this stuff, you know, you're not just going to pick this up in a day, you know. um this is great. This is really really good. Okay, moving on. So we snippets, replicator, let's have a swatch, synthetic data recorder. Let's have a look in here. Oh, was it just in here? It may have just been, sorry. Yeah, because the synthetic data recorder, they've not changed that. I think I've actually spent more time working on explaining how things work, which is really good, you know. Um, Point cloud, including label. See, I want to know, have they actually fixed this? Because see, when you used the point cloud before, they actually used the camera. So uh even if your sensor was like what would you call that? Um, Even if your sensor, you tried to capture the RTX lidar synthetic data from that, from this the default, and you selected point cloud, it would actually generate a point cloud from the camera to the resolution that you can see here, which wasn't very good because that's not what because that's not going to be the sensor. The only other one is whether you do an occupancy map. It's yeah, I'm not a big fan. Um, custom writer examples. I think this is pretty much yeah. They've done a little bit more work here as well. Very cool. Um, yeah, great again. Um, I think like definitely just digging into this stuff is a great way. Snippets and features, data augmentation, randomization snippets. Let's have a wee look at the annotator. Useful snippets. I mean, there's loads of stuff here. Do you know what I mean? It's like you could spend hours talking about this stuff, and really dig into the code. Um, Scene setup and assets. We don't need to do all that. Robot simulation. We'll just have a flick through that. Quadruped. So you've got quadruped, which is obviously quad 4. So that's like your dog. So that's like your spot and stuff like that. Articulation and inspector extension. Right. So this will be again degrees of freedom and inverse kinematics. Blah 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 blah. Yeah, a lot in here. A lot going on there. I'm not going to fry my brain. Try to go over that. Surface gripper. Yeah. Uh, oh, that's cool. Don't know what they're doing there. I would need to. I think this is just like whether it's a sort of sucker or something. I don't know. I'm not going to try and just go over this. Right. Oh, let's have a look at the graphs. Right. Close. Yes, there's a lot here. You really need to spend a lot of time going through this stuff. It's just don't have enough time. Let's have a look at this tuning thing. Use a guide. Yeah, stiffness and good dampening gains. Trajectory with marginal error. Tune the gain. Blah blah blah. Yeah. So yeah. So this is cool, right? So basically, it's your ramp up, ramp down time. So in reality, when you're using different systems, you don't want it to just come to a stop because you've got mechanical load there. So if you want something to move fast, like if you imagine driving in your car and you just go from 30 miles to zero, you're going through the windscreen, and that's what you don't want to happen with your robot. So this looks very cool. This cool, man. This is cool. I'm into this. They've done again. Hats off, brilliant. Loads of work here. This is clever. I like all this stuff. This is they've done a good job here. Like the way that they've done it, and like it's visual as well. I like visual. I like to look at stuff. Because I think sometimes when you look at code, it's just numbers and you sort of zone out. But it's good that you get the visual thing. Okay, sensors. Oh, here we go. Let's see how well have they done. Let's see. RTX LiDAR, RTX radar. We'll have a wee quick look at the cameras just quickly. Right, so okay, right, it's just a camera. What's this? So I think that is right, so it's basically camera calibration. So that's more to do with the fisheye. I think this is to do with the fisheye, like of the lens and stuff, so that basically when you are calibrating, it's width, matrix height. Yeah, it's all like aperture and stuff like that, the focal length. So yeah, aye, right. So basically, what they're saying here is you want to take your camera and then get your camera properties so that the way that the camera looks, the camera that you're planning to use, that you're going to run inference on, you can sort of simulate that in Omniverse. So that's brilliant. That's another good one. I'm not going to go. I mean, it's all open CV stuff, right? And they kind of showing you how to calibrate this and that. So that's another belter. Right, here we go. Right, because I harassed them all the time. Let's see if they changed much to this. Let's have a look at the code. They updated this because that was wrong in the previous documentation. You had to look that configs. I don't think they've updated it. So they've added some new sensors. sense materials. Yeah, I think this is going to be the same actually. So this is the action graph, right? I think maybe some of this has changed. See, you have to. I don't like the way they've done this. Like, I don't know why we need all this, right? I don't know why we need a graph like this. I just I can see why there is some stuff that I think is good here, and there's some stuff I just don't think you need. Like, but there will be reasons that they've done this. They've not just done this for the good of their health. That they've done this for whatever. I would need to read through this properly. I'm just sort of like running through this. Again, they keep using this example rotary, which I don't even. Yeah. So a lot of this is linked to like Drive Sim and stuff like that. So let's go back one. It looks pretty much similar. They haven't updated these docs in this section. Let's go into nodes. That's good. Looks pretty. I think they have. I think they have done some updating on this. There was some stuff I played about and I couldn't get it to work with the nodes. This is pretty much the same. Ah, right. This is the one that I think that they really want you to use is the buffer because it's to do with how the information is stored. So if you want to take information 25 frames a second, for example, because maybe you're running a camera and a LiDAR, right? So the cameras run at, I don't know, actually, the Americans might run 30, like we'll just say 25, right? So your camera's running at 25 frames a second, but your LiDAR head's only running at 10, right? So you need to, every time that's collecting that data, once every 25th of a second, you're only going to get a section of the LiDAR, right? But if you have a buffer that sort of stores everything until it's updated, until the new um that new point, say there's 50,000 points, that that's going to get, so say it's 20 frames a second, you're only going to get 10,000 of these points per, so it'll be like blocky like that. So this is kind of what they want you to use is more this, so you'll get your you create your buffer. There's a lot of stuff in here I'm not going to go through just now. Um, yeah, and it's just that's all just your nodes and stuff. Config files, that's like basically what that is. It's just giving you, your resolution, your frequency, um, so it's something I need to look into a bit more. Sensor materials, this is kind of new. I think it was in the last version, but basically I think it's to do with intensity of the return, and depending on the material property, it gives you different intensities, so you can put that also in your training data. And the LiDAR config JSON is basically where all the stuff is stored. Okay, okie dokie. Um, radar, that's, I don't know about that. Like, I don't know enough about radar to even go into this, but there's some stuff I want to look at that later. Physics sensors, uh, LiDAR extension. What's this? Right, so what's all this? This is new. This is new. So I'll need to go and have a look through all this because the guys have done, and this all because this is sort of the API stuff. Right, okay. Right, and then they've got the radar. Non-visual, I don't really know. Let's try and figure out this. Right, I need to read this properly because I don't want to butcher it by just talking about it and I don't know what it's talking about. Debug, mapping. Right, let's do a bit of mapping. Right, this, I seen this earlier. So you get your occupancy map, right? Yes, very, very good occupancy map. So again, this is Right, okay. So yeah, occupancy maps. This is sort of like block world, right? Aye. Yeah, so basically what you're doing is you're creating this sort of these scenes, and then yeah, basically you try to get your robot through and then it'll see. But this is like there's going to be a lot there's going to be a lot in here, and good cell size, right? That's good. Right. I wouldn't ever play with this, but this is something I definitely want to ever play with because this is something warehouse logistics. This will be out for a lot of people, but this isn't for me. Because if we look at the people though, okay, all right, the people look looking a bit better. So you get the if you want to simulate people, all good stuff. I'm not going to go into that. Motion generation, yeah, API, yeah, policies, path planning, kinematic solver, all good stuff. A lot of information here. Um, Cortex, aye, this is not going to be simple because this is sort of talking about quite abstract. Um, Future versions will be independent. Cortex is deprecated as of 4.0. Future versions will be independent of Isaac Sim. Hmm. So that means, uh, yeah, it's good that they put the GTC talk in there. I would need to read this more because obviously there's a lot of stuff here, and I don't want to, again, butcher this. I'm going to kind of close this up in a minute, actually. Yeah. So basically, future versions will be independent of Isaac Sim. So what that says to me is that Cortex, which is sort of like the brain concept, is is basically going to become its own thing outside Isaac Sim, which probably isn't a bad idea, um, as long as it can sort of be. I mean, it would be able to be integrated, because that this is like a really the con the concept behind this is really important, and I think that's something that we should really think about is like there's a lot in this because what you're trying to do is try to explain how the brain works, right? That's the whole point of cortex, so it's like decision making, um, and you can't just use if statements. This is the whole point of why AI is so great. You can't use if statements. So cortex, there's obviously going to be a level of if statement. Whether that's even including this, I don't actually know. But it's basically to make things smarter, right? But it's kind of you've got a environment, you've got actuators, you've got sensors, and you've got a goal, and it's how you carry that goal out. So this is yeah. There's going to be a lot in this, and I'm not going to try and go through it and butcher it again. Because it's quite a complicated thing. It's something you really need to think about quite deeply. Uh, you know, Something you need to think about quite deeply and then go into it, right? So a lot here. Um, Python environment. Yep, I need to go and have a play with this. This is a big one, right? You need if you're going to play a bit with this stuff, simulation app class, right? That is what you really need to get into because it's sort of from Isaac Sim. Right, okay. Carb, blah 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 blah. Yeah, standalone. Yeah, another one you want to maybe go and look at is if you're having problems, you want to do this time stepping. idea. So you want to just sort of go frame by frame and then see what's going wrong. You can use your logs, you can do whatever, you know, Jupyter notebooks, there's a lot of stuff here. VS Code support, right? Yeah. So probably need to dig into this. This is the one. Basically, yeah, you want to run this the kind of debug. You want that attached, and so you can sort of have your USDA open, because that's human readable. You might have that. Okay, so that was in before. I like the idea they've sort of made something a bit more linked, that you sort of can use script node and VS Code. Well, use VS Code as script node, because script node was a pain to work with. Um, also script node, script editor inside Isaac Sim. VS Code was really good tool. This again something I need to look at. Utility, robot simulation. Yeah, look, API docs. Right, and I've not even opened Isaac Sim here, and I've spoke about it for an hour now. Right, so I think that's going to do us for today. I'm going to go and have a play with this, and right, cool, enjoy.